Today we're going to look at geometric sequences. Geometric sequences have multiplication or division patterns. More specifically, multiplying by the same number to create each new term, or dividing by the same number to get each new term. The number that you are multiplying by is called the common ratio. So if the pattern is multiply by 2, then your common ratio would be 2. You're multiplying by 2 each time to get the next term. If your pattern is divide by 5, say we start with like 200. We divide that by 5, divide it by 5, divide it by 5, divide it by 5. R is supposed to be the number that you're multiplying by. Division is the same as multiplying by the reciprocal. So if your pattern is dividing by 5, your R would be 1/5. So keep that in mind when we're finding R. If it's a division pattern, you have to take the reciprocal of what you're dividing, and that's what you're multiplying by. In 1, 2, and 3, we need to decide, is this geometric or something else, and explain our reasoning. So number 1, how do we get from 2 to 6?
3 times multiply by 3.
Multiply by 3, 6 to 18, multiply by 3, multiply by 3, multiply by 3. So yes, this is a geometric sequence, and our reasoning, our common ratio is 3. We're multiplying by 3 each time. Number 2. 2 times 3.5 is 7. 7 times 3.5 is like over 21, so that's not it. It looks like it's adding 5 each time. And if it's adding 5 each time, that is not geometric. We learned yesterday it's arithmetic. Number 3, 6 times 2 is 12. 12 times 2 is not 20, so it's definitely not geometric. It's actually adding 6, adding 8, adding 10, adding 12. That would not be geometric or arithmetic. That would be neither. The formula for geometric sequences is an exponential growth formula. The nth term is the first term times the common ratio raised to the n minus 1. This one doesn't have parentheses, so we don't have to distribute, we don't have to simplify. If you know your first term and your common ratio, you drop it into the formula and then you're done. So geometric formulas are sometimes easier than arithmetic because they involve less work. So in this example, number 1, our first term is 3. We need to figure out what our common ratio is. It's multiplying by 4. Once we know our first term and our common ratio, we can write the nth term equals the first term 3 times the common ratio 4 raised to the n minus 1. And that's it. We have our rule for this geometric sequence. Then find A7. This means we need to find the 7th term. So we plug in 7, 3 times 4 raised to the 7 minus 1. I'm going to write this in red so you can see how terribly wrong it is. This is not equal to 12 to the 6th. Does the word PEMDAS mean anything to you?
Yes.
Exponents must happen before multiplication. So this part, 4 raised to the 7 minus 1 must happen before you multiply by 3. So never, ever, 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 ever do the multiplication before the exponent. Always make sure you do the exponent first. Or if you have a scientific calculator or a graphing calculator, just type the whole thing into your calculator. The exponent 7 minus 1 is like a grouping, so you can do that 7 minus 1 in your head. That would be, 6. So you can do 3 times 4 raised to the 6th. 3 times 4 raised to the 6th. Our answer is 12,288. So the 7th term is 12,288. Geometric sequences either get very, very big very quickly or very, very small very quickly, because really they're the same as exponential growth and decay functions. Okay, number 2, our first term is 36. We need to figure out what our common ratio is. So let's figure out what is the pattern. We're dividing by something. 36 divided by, ignore the negative for right now, 36 divided by what is 12? 3. Now if there's a negative in there, that means we're dividing by -3. So 36 divided by -3 would be -12. -12 divided by -3 would be +4, and so on. When you're multiplying or dividing by a negative, you're going to see that negative, positive pattern. Now, division, our R value has to be multiplication, so our R value is -1/3. Once you know your first term and you know your common ratio, you can write the formula. A sub n equals 36. It's probably best to put that -1/3 in parentheses, raised to the n minus 1. To find the 7th term, we're going to plug 7 in place of n. So 36 times, I forgot to write my negative, didn't I? Times -1/3 raised to the 7 minus 1, which is 6. We get this decimal. We could round, but I'd prefer it if we didn't have to. We should probably write this as a fraction. Do you see how that last term that it shows us in the sequence is written as a fraction? In your scientific calculators, you can do second ABC button. On the graphing calculators, you press math button, enter, enter, and it changes it to the fraction 4/81. So the 7th term is +4/81. To write the rule for the nth term, you must have your first term and your common ratio. This problem tells us that the common ratio is 3. It does not tell us what the first term is. So we're going to have to do a little bit of work to go backwards and figure out the first term. Then we can write our rule for the nth term. So if I use the formula, nth term is the first term times the ratio raised to the n minus 1. I know that I don't know my first term yet. I do know that the common ratio is 3. A sub 5 is 54. 54 is going to go in place of A sub n. And because 54 is the 5th term, we will use 5 in place of the n. So 54 is the 5th term. Use n equals 5. We can do this part in our calculators. 3 raised to the 4th is 81. How do we undo times 81? Divide by 81. And in our calculator, 54 divided by 81 gives us the decimal 0.6 repeated. Do you know what fraction is 0.6 repeated? 2/3. If you don't know that, use your calculator's fraction features to change it back to a fraction. Our first term is 2/3. Once we know that our first term is 2/3 and our common ratio is 3, this is where this problem is easier than arithmetic because we don't have as much work to do. Your nth term equals your first term 2/3 times your common ratio 3 raised to the n minus 1, and you're done. You have the rule for the nth term.